My screen. I hope my screen is also visible. Okay. Now, what we have discussed yesterday is we have discussed the related things to our course. We have seen some of the introduction, what we are going to see, and some of the prerequisites we have seen, and what are the different projects that we are going to do in this course, Jenkins, Docker, and Kubernetes. We have seen. If anyone are new to this class or to this course today who have joined, please the video will be uploaded in YouTube. Uh, you can view that thing there. What are the different contents we have seen? We are going to see that we have seen like that. Okay, you can see that things there actually, and you can also find the content what we are syllabus. I mean to say in the DURGASOFT website, and this is that syllabus. That's a thing. Okay, Jenkins, Docker, and Kubernetes. Okay, that's the thing. Now, what we are going to discuss today is about the this is our agenda today. Like, what is DevOps? What is an application that we will be discussing? And what is SDLC? What is server? What is physical server? What is Docker and Kubernetes? Where does Docker and Kubernetes fits in SDLC process actually? So we are going to see all these things today. Okay. Now, what is DevOps actually? What is DevOps? DevOps is a combination of development as well as operations. Okay, it's a combination of development as well as operations. It is not an application development that we do in DevOps, but we are going to develop in DevOps as part of development. We are going to develop scripts. Okay, we are going to automate things with the scripts. The activities which we are doing regularly, manual activities that we are going to do, we are going to automate as part of development in DevOps actually. Like, it may be the Python scripts, it may be the shell scripts, it may be the Groovy scripts, and it may be the Terraform scripts, whatever scripts it may be. So that comes under development in DevOps actually. So what is operations? What is operations? Operations is maintaining the infrastructure. Like, whatever the infrastructure. What is infrastructure? Servers, memory, CPU, okay, different software. So that are all called infrastructure. Okay, networking. So that's the thing. Okay, maintaining the infrastructure, like regularly providing the updates, security updates, regularly updating with the new version of the software. So these comes under operations in DevOps, as the DevOps contains many tools in each of its stage actually. So the DevOps contains many tools actually. We are going to see the different stages in DevOps in the future. So that's the thing. Okay, that is development and operations is a combination of DevOps actually. So now, what is an application? Application is nothing but a website. So we will in our regular thing, in our regular life also, we are going to see many applications, right? We are going to access the Amazon.in application, Flipkart or Mintra or whatever it is, Redbus. Those are kind of application. Now, how you are able to access that application from your web browser? Because that application is placed on a server. Okay, is placed on a server. Okay, that may be any server, physical or virtual server, is placed on a server, so that you can be able to access that application from your place actually, so that it is you can do perform the functionality that application gives for us actually. So that is an application. Simply, in a simple words, application known as a website that we regularly in daily access actually. That's an application. Now, see how the applications are developed in the real industry. So they will be following some processes like SDLC, one of the example, agile. So that's okay. These are some of the process they will be follow. Okay, in order to develop their application. So already you people know. Let me discuss one thing. Okay, one more time. Okay, so there are 6 phases on in SDLC, software development lifecycle process. Okay, first phase is the requirement phase. Okay, in the requirement phase, what the people are going to do is they are going to collect the requirements, like how much, what are the things that is required to develop this application, like how many amount of resources required. So is there any extra workloads required, how much amount of space required, or how much amount of servers required, all the requirements. Okay, all the requirements from the clients, how the web page should look like. Okay, so all the requirements from the client will be taken actually in the requirements or analysis phase. Okay, this is the first phase of SDLC process. The second phase, that's a design phase. There will be a designers, okay, like ux ui ux designers, or the system design that the people are going to do in the design phase. They like, for an example, let me tell you, okay, in if you want to log into any application, you need to first enter your username and password, right? So where that username and password screen appear should be appear on your page, whether it should be on the middle, or whether it should be on the top of the page, or whether it should be on the middle of the page or the bottom of the page. That kind of design will be decided in the design phase actually. Once the design got completed by a UI UX design or a system design, we have something called design patterns that we follow in order to design an application, something like that. So once the design for the application got completed, now they will give the design to the development people. Okay, developers will be developing that application, whether it's a front end or back end. People in the development phase will be developing the application. They will choose one programming language, like whether it is in the front end Angular or React or something like that. So, and from the back end they'll be choosing Java, .NET, Python, whatever they choose, that whatever they feel that is a better language, so they will be choosing that the language, and they'll be developing the program for that application actually. Once the development got completed, after that, in the development phase, developers will also write unit test cases for in order to test the application. It's called initial testing that the developers does. Okay, unit test cases will be written by developers only. Okay, so there will be a different frameworks developers follow, like JUnit, Mockit, or PowerMock, or in case of Java. So people will follow different frameworks in order to develop the test cases. So once the development and test cases got completed in the development phase, that software which is developed will be moving to testing phase. Okay, in the testing phase, testers will be there. They will be performing different types of testing. Okay, A by B testing, regression testing, performance testing, any testing. So all this testings will be performed in the testing phase of the SDLC process on the developer software actually. Once the testing phase got completed, it is our important phase where the Docker and Kubernetes comes into picture actually. Deployment phase, the applications which is developed by the developers is going to be deployed on the servers actually. In the deployment phase, the way the people are going to deploy the microservices or the applications is using Docker and Kubernetes. Where does Docker and Kubernetes fits in SDLC process? Here in the deployment phase. Okay, deployment, Docker and Kubernetes comes under deployment phase of our applications to servers actually. Once the deployment has been completed, then the last phase, the final phase, will be maintenance phase. So in the maintenance phase, what will be there? So regularly maintenance will be there, like providing the security patches or providing the application updates, and regularly releasing the updates to the production or the development environments. So such kind of maintenance will be there in the maintenance phase. So the important phase for us for our course is the deployment phase, where our Docker and Kubernetes comes into picture actually. So that's the deployment phase here is where the Jenkins switch, it is used to automate all the things, testing, deployment, and the maintenance. We'll see further, but yeah, our Docker and Kubernetes comes under deployment phase of SDLC process actually. So that's the deployment phase. Once the deployment got completed, where that is deployed to? On a server actually, where that software will be deployed to? On a server. There are many types of servers. How the people used to deploy previously, before 10 or 15 years, their applications, how the people used to deploy? They used to deploy on the physical servers. Okay, physical servers, because there are many disadvantages if they deploy their applications on the physical servers. Because of this disadvantage that we have physical servers, if you deploy their applications on the physical servers, so there is something called virtualization concept has been evolved, and there are also disadvantages in the virtualization and virtual machines. We will be going to see all the things today actually. But as an introduction, there is also a problems with the virtualization and the virtual servers. Then the people move towards the Kubernetes, like Docker, and there is a problem with Docker. Because of that problem with Docker, then the people move towards the Kubernetes actually. So in that kind of chain, we are going to discuss the concepts. Okay, so that's a server actually. Server is a server where we deploy. It's a physical machine where we deploy our applications to. That is a server actually. Now, where does Docker and Kubernetes fits in SDLC process? It fits in it fits in deployment phase of the software development lifecycle process, actually deploying applications to physical servers. Previously, as I already told you, previously in the previous times, like 15 or 20 years back, the developed applications by the developers, people used to deploy their applications on the physical servers directly. So what are the different disadvantages that we have if we deploy our applications on the physical servers? Let's see one by one. Let me select all these things. Let me remove these things. Okay, now let's assume this is a physical server. This is a physical server. What is a physical server? The server, the machine which we can touch and feel is called physical server. Your laptop is a physical server. Okay, your laptop is a physical server. Okay, that's a physical server. People, let me label it as physical server. This is a physical server. This physical server will be having some amount of resources. What are the resources? Resources means some amount of CPU and some amount of memory. Okay, let's think this physical server has 10 CPUs and 10 GB memory. Let's assume that one. Okay, 10 CPUs and 10 GB memory is there with this physical servers. Now I have deployed an application to this physical server. I have deployed to this application to this physical server. Now this application name is, let me take this application name is app1. App1 is the application name. So this application only requires 1 GB of RAM and one CPU it requires to run properly. Okay, it only requires 1 GB of RAM and 1 GB of one CPU it required actually. Now this is the main disadvantage here. Now one only application is only required 1 GB and 1 CPU, but this physical server has 10 CPUs and 10 GB memory or the RAM. Now, what about the remaining 9 CPUs? What about the remaining 9 CPUs? The left out CPUs and memory will be 9 CPUs and 9 GB memory. These are the remaining actually 9 CPUs. Once again, 9 CPU and 9 GB memory. Okay, that's that is the resource wastage that we have with the physical server. That is the resource wastage that we have with the physical server. Let me write the disadvantages with the physical server here. Let me put it here. Okay, disadvantages of deploying applications to physical servers. Actually, the first disadvantage that we have seen is resource wastage. The resource, what is the resource? CPU and memory wastage. Okay, that's a resource wastage. Okay, this is the first disadvantage that we have in case of physical servers. So what is the second disadvantage that we have with the physical servers? So in as part of second disadvantage, so if I want to deploy multiple applications, I need multiple physical servers. Right? So in order to deploy multiple applications, in order to buy the physical server, that will be a huge cost, and we are unable to spend that much amount of cost in order to deploy multiple applications. So the second disadvantage, if we deploy our if we deploy our applications to physical servers, is the huge cost. Huge cost actually. This is the second disadvantage that we have if we deploy our applications to physical servers. Now the third disadvantage, so I have a money and I have bought multiple physical servers, we need to have a big space to install that physical servers. We need to maintain that physical servers, so we need to regularly provide the security updates, and we need to regularly deploy our applications. So there should be a separate team to maintain that physical servers, so that is the fourth disadvantage is there. That is a huge maintenance. Okay, huge maintenance. Actually, there's a fourth disadvantage that we have. Actually, this is a fourth disadvantage. And what's the next disadvantage that we have if we deploy our applications to physical servers is if any particular physical server had a problem, if any particular physical server where our applications are running have a problem, and someone got terminated or someone deleted or whatever it is, there is a problem with that physical server, and the applications which are running inside that physical server will also be having a problem. They will not be accessible to the external users who are using that application. So that's no disaster recovery mechanism that is there with the physical server. That means if any problem appears with the physical server, there is no mechanism. So it should not, it will not be automatically come up. It will not be automatically deploying the applications. A manual things are involved to perform that activities. So there is no disaster. If any disaster happens, there is no mechanism to recover that disaster. So that is the disaster recovery mechanism is not there with the physical servers. Disaster recovery disaster recovery mechanism is not present with the physical server. Like this, there are hundreds of disadvantages with the physical servers. Actually, let's stick to this. The one is resource wastage, huge cost, huge maintenance, and disaster recovery mechanism. So because of this disadvantages, because of the disadvantages that we have with the physical servers, the industry went to something called virtualization and virtual servers. So that's how the virtualization is evolved from the disadvantages of the physical server that we have if we deploy applications on the physical servers. Actually, now how the virtualization or the virtual servers looks like, let me draw a diagram for you. Like, this is the physical server. In the virtualization, there will be there is also a physical server. Okay, this is a physical server. Let me label it as physical server. Let me label it as physical server. This is a physical server. This physical server has 10 CPUs, 10 CPUs and 10 GB memory. Okay, 10 CPUs and 10 GB memory. On top of this physical server, there will be a operating system. There will be a operating system. Any operating system. Let me take the whole operating system OS. There will be a operating system OS. Okay, this is an operating system that we have actually. Now, on top of that operating system, industry has deployed something called virtualization software. Okay, virtualization software. What this virtualization software does for us, let's see further. But there will be a virtualization software on top of this operating system inside the physical server actually. So there are multiple virtualization software available in the market. VMware, okay, VirtualBox, okay, and Hyper-V, hypervisor. So those are some of the virtualization softwares actually. Let me take the virtualization software that will be deployed on top of the operating system inside the physical server. Actually, virtualization software that will be deployed on the operating system inside the physical server. Once the virtualization software is installed, what the functionality of this virtualization software, why we installed this virtualization software within the physical server, the functionality is this will allow us to divide a physical server into multiple servers actually, so some of you people might be already installed VirtualBox. What the VirtualBox does for us, you have installed the VirtualBox from your wherever internet. Okay, that VirtualBox is allowing you to create one more server or one more machine in your same laptop. Okay, that means your laptop is a physical machine, and inside your laptop VirtualBox you have installed VirtualBox, that is virtualization software that will help us to create one more machine inside your laptop. That is the virtualization software. Now that's the same concept applies for this also. Let me draw a diagram for you. This is one server. Okay, one server. Let me copy this. Let me paste it here. Virtualization software will allow us to create multiple servers in the one server. Actually, one second, one physical server I meant to say. Let me put the diagram here. So like this. Okay, now this servers, the internal servers which were created on top of one physical server, is called virtual servers. Okay, the internal servers which we created inside the physical server is called virtual servers, and they are also called virtual machines, or in AWS they'll call EC2 machines actually. So this is called virtual servers. Let me put as a shortcut name VM. Okay, VM. Okay, this is a VM means virtual machine. Okay, VM. Okay, any name you can call that one. One second. VM actually. So these are called virtual machines. Suppose now what will happen if how this virtual machine will help us actually. Previously, if I want to deploy multiple applications in case of physical server, I need multiple physical servers. But if I here in this physical server and virtualization concept, I can deploy multiple applications into one physical server actually. So this is a physical server in which our virtual servers are there, virtual machines are there, right? Now I can deploy multiple applications. Suppose this is the one application I have deployed, and this is the one application I have deployed, and this is the third application I have deployed. Now each virtual machine will be having some amount of resources. Okay, some amount of resources. So that will be taken from the physical server only. Here 10 CPU and 10 GB memory is there. Now if my virtual machine will be allocated some, let's take an example, 3 CPUs and 3 GB memory, and let me copy it from here, and this virtual machine also allocating this much amount of memory and CPU. This virtual machine is also allocated this much amount of CPU and memory. So each machine has this much amount of 3 GB and 3 GB memory and 3 CPUs that we have, and remaining 1 GB and 1 CPU is used by the OS and the virtualization software that is installed on this physical server actually. Now we have deployed 3 different applications on 3 different servers. Previously, in case of physical server, if we want to deploy multiple applications like this, we need multiple physical servers. But in case of virtualization and the virtual software, so we can deploy multiple applications like this. We have multiple applications deployed on the same physical server. You can see this. We have deployed on the same physical server. That is the virtualization and the virtual machines actually. This is app 1. Okay, this is app 1. This is app 2. And this is application 3. App 3 actually. Now, here, instead of buying multiple servers, I can only buy one server. Okay, one server only. I can deploy multiple applications. So there will be a very reduction of cost. Okay, there will be a huge reduction of cost. That means this advantage, if we use virtualization, is resolved. Huge cost has been resolved actually. Now, huge maintenance is the another disadvantage that we have if we deploy our applications to the physical servers actually. But here, if we want to deploy multiple applications, we need multiple physical servers, because that's the thing. Okay, now, but in case of virtual servers actually, or the physical server, in case of virtualization, we can deploy multiple applications on the same physical server. Instead of maintaining multiple physical servers, I am maintaining one physical server only in case of virtualization. So there will be a huge reduction of maintenance in case of virtualization. The disadvantage with the physical server is huge maintenance, and that is gone in case of virtual server or virtual machines actually, because instead of maintaining multiple physical servers, we are only maintaining one physical servers in which multiple applications will be running actually. Now in case of physical servers, we don't have any disaster recovery mechanism, but in case of virtual servers, we have disaster recovery mechanism. If one virtual server has been deleted or killed, or something happens to one virtual server inside the physical server, a new virtual server will be automatically created and the applications will be automatically deployed. Actually, that kind of disaster recovery mechanism that is there with the virtual servers actually. So this also is gone. These disaster recovery disadvantages that we have with the physical server is gone with the virtual servers actually. So now the other disadvantage is resource wastage that we have seen. Okay, now our machine has 10 CPUs and 10 GB memory. Our physical machine has 10 CPUs and 10 GB memory. The 3 CPUs and 3 GB memory is allocated to 3 different virtual machines, right? Now, our application, let's think our application only requires one CPU and 1 GB memory. So, one CPU and 1 GB memory. One CPU, one second, let me put it here, one CPU and 1 GB memory. Now, if my application only require one CPU and 1 GB memory, and what about remaining 2 CPUs and 2 GB memory? What about remaining 2 CPUs and 2 GB memory out of this virtual machine? Okay, out of this virtual server, there is a resource wastage that is present in case of virtual servers actually. Okay, one second. Remaining is 2 CPU and 2 GB memory is still present. Okay, still is ideal actually. So that is the resource wastage that we have in case of virtual servers actually. Because of this disadvantage, something called resource wastage, there is another reason, something called evolution of microservices. The Docker has been evolved in the market, okay, because of this. Okay, now in case of Docker, how the infrastructure is going to look like, how our diagram is going to look like actually. So now let's think. This is the physical server. This is the physical server actually. Now this is a physical server. On top of this physical server, there will be operating system. I already told you in case of this virtualization, this is an operating system that we'll be having. On top of this operating system, we will be having virtualization software. On top of this virtualization software is a previous example, same thing. Okay, on top of this virtualization software, we will be having physical servers. I'm taking only one virtual servers. I am taking only one virtual server for my simplicity and easy purpose for you actually. Okay, so I'm taking only one physical server, one virtual server inside the physical server. There will be many virtual servers, but for an example, I'm taking one virtual server inside the physical server. Okay, now what will happen? What will happen here is now. Let's think I am taking this virtual server is let me take this one as this a physical server, physical server, and this physical server has 4 GB memory and 4 CPUs. Okay, 4 CPUs. Now out of this virtual machine inside the physical server got allocated like 3 GB memory and 3 CPUs, 3 GB memory and 3 CPU actually, 3 GB memory and 3 CPU got allocated to this virtual server or virtual machine. Now in the virtual server also there will be an operating system, something called guest operating system. There's something called guest operating system. This is a guest operating system. On top of guest operating system, we are going to install Docker. Okay, we are going to install Docker. Okay, let me put that names here. Let me label them. Okay, guest OS and this is Docker. Okay, Docker. We are going to install Docker. If you install Docker on top of this virtual in the virtual machine, what this Docker can do for us is we can run multiple containers like this. You can, this is the first container, this is the second container, okay, this is the third container, okay. Entire resource will be properly used actually. 3 GB memory and 3 CPUs will be properly used actually. Suppose let's think this this is using 1 GB memory and 1 CPU, and this is the second application that is using 1 GB memory and 1 CPU, and this is third application is also using 1 GB memory and 1 CPU. Okay, 1 CPU actually. Now entire resource, that means entire virtual machine, entire resources, that means entire CPU and entire memory that is allocated to this virtual machine will be properly used in case of Docker. That is the resource wastage will be gone in case of Docker that we have in case of virtual machines as well as in case of physical machines if we deploy our applications to the virtual machines and the physical machines. Now, one more reason why the Docker is evolved is the evolution of the microservices in the market. That is another region. Anyway, we are going to deploy multiple microservices into our Kubernetes clusters or the Docker containers. So we are going to see at that time how the microservices communicate with each other in case of Docker containers. Actually, what is a container? Okay, in case of Docker, we will be telling the word called container. So container is a thing. Like, what is a real container means? In our society, what is a container? It is used to ship the goods from one place to another place. In the same way, inside the container in the Docker, our applications will be in running state. Actually, the applications will be there inside the real container. The goods will be there, but here in the Docker, the application will be there. That's a container. Anyway, we are going to discuss in the Docker. Okay, this is how the Docker is evolved. Docker solves our most of the problems. It runs our applications as a containers actually. So that will remove the dependency between the operating system and our Docker applications actually. So that's how the Docker is evolved from the previous world to the current scenario. Okay, that is how the Docker is evolved actually. So if you have any questions, please ask. Any questions anyone has, please. Any questions anyone has? This is the introduction. We have not yet started Docker. Any questions anyone has? Okay, how the Docker is evolved. If no, please put the no in chat box. Okay, okay, yeah. Okay, now this is how the Docker is evolved. Now you need to understand we are going to run our microservices as Docker containers, with the help of Docker actually. Now you need to understand how the microservices will be designed, how they will be communicating with each other before going to the Docker. Let's discuss that one by one first. Okay, now let me go to new and how the applications are there previously, how the microservices are there now. Let's discuss one by one. Previously, there used to be having a monolithic applications. Suppose let's take Amazon.in as an example. Okay, now there are different functionalities that Amazon.in provides for us. That is, one functionality is in order to do the payments. Another functionality is in order to do the shopping for the clothing, or in order to do the shopping for the electronics. Okay, in order to do different function. Amazon Pay is one of the functionality. So there are different functionalities that Amazon.in gives to us actually. Now, all that functionalities is developed as a single application in the previous times actually. That is called monolithic application. That is called monolithic application. Now let's think. Let's take clothing. Okay, clothing is one of the functionality, and electronics is another functionality. And let me take the payments. Okay, payments is another functionality. So there are different functionalities like this. Okay, there are different functionalities like this as part of Amazon.in application that is developed as a whole, as a single application, that is called monolithic application. So like this examples goes in the big list actually. There are many functionalities. Okay, let me label it as the Amazon dot it, and this is monolithic. Okay, lithic application. Okay, monolithic application actually. So this is the monolithic application. Now, because why we call it as monolithic application, entire functionality of the application, all the different functionalities of the application is developed as a single application, that is monolithic application. So there are many disadvantages if we deal with this monolithic applications. Suppose tomorrow a new bank got has been come into the market, something name, let me give the bank name as ABC. Bank name is ABC Bank. Okay, the bank name is ABC Bank. Now, our Amazon requirement is they should allow the payments with this bank also. This bank also need to be allowed for the payments from their application. Now, in order to do this small change, adding a bank to the monolithic application, there will be a huge dependencies between these applications. The code they are going to change is huge actually. Suppose if you want to add any bank to this application that related to only payment section, that change is only related to payments thing. That change is only related to payments thing. Okay, right? That only the adding of bank is only related to payments thing. But entire application will be getting affected, because in case of monolithic application, the dependencies between each other will be there. There will be huge dependencies between each other. If you add a bank to the payments, the electronics functionality will need to be changed. If you add any changes in the electronic functionality, there will be a clothing functionality need to be changed. Such kind of dependencies will be there in case of monolithic application, and that is a one disadvantage that we have with the monolithic application. Now, another disadvantage is, let's suppose this is a monolithic application that is developed as a whole. The entire application is developed as a single application. Now, let's think this application takes 20 minutes in order to restart, because when you add this bank to this payments application and everything you develop and everything looks fine, looks fine actually. Now, if it should be reflected in the production, right? If because of this, all the functionalities are together in this monolithic application. Let's think this application, this entire Amazon Amazon.in application takes 20 minutes to restart, because all the functionalities need to be started, all the functionalities need to be connected to database. So all the things which need to be done takes 20 minutes to restart the monolithic application. So you can think of how much big impact for the Amazon.in business impact it is for the Amazon people. 20 minutes will be 20 minutes up. If the application goes for 20 minutes, down for 20 minutes for a simple ABC bank payments change, actually it will go for, if the application goes for 20 minutes, there's a huge business impact for the Amazon people actually. Because of this, some kind of these reasons, there are many reasons. Let's stick to this. Okay, one is the dependencies reason, the other one is the restarts reason, the maintenance reason. Okay, because of these reasons actually the microservices got evolved. So how the microservices looks like, actually, each and every functionality within the monolithic application is developed as a separate application. In case of microservices, now it is developed as a separate application. Suppose, let's think this application is clothing. Okay, clothing, this is a clothing application. Now the another application that we have is the electronics application. Let me think this one as electronics. This is the electronics application. The another application that we have is the payments application. Let me draw a diagram like this. Payments application. Now there will be a communication between the clothing can able to talk to the payments, and the electronic they can be able to talk with each other, and the electronics can also be able to talk with each other. Okay, now like this, and the clothing electronics can also be able to talk with each other. There will be a communication between all the different applications within the microservices architecture using the APIs that we call it as the application programming interface. This is also a Amazon.in application, Amazon.in application. Okay, in this case, in the microservices world, or individual functionalities of the Amazon.in application is developed as a separate applications. Those are called microservices. Suppose here in this case, if I want to add ABC bank previously in the monolithic application, entire application need to be restarted to reflect that change in the production environment. But in this case, in the microservices application, in order to add this ABC bank, you will be only changing the payments application. You will be only changing the payments application, and you will be only restarting the payments. The remaining clothing and electronic goods remaining application will be running as it is, but you will be only doing the changes to this application, and you will be only restarting this application. Now, because of this reason, let's think this application takes only 5 seconds to restart. Okay, you are going to see in real in the Kubernetes cluster how much time it takes. It's going to restart in very less number of seconds, within less than 10 seconds actually. So it takes only 5 seconds to restart the payments application in case of microservices. You can see from 20 minutes of the restart of the application, if any new change has been occurred to the application, to the 5 seconds restart of the application in case of microservices. So how much the reduction, how much the time difference is there, you can think of. Okay, so this we will be having many advantages if we deploy our applications as microservices in case of microservices from the monolithic actually. Now, why I am explaining all these things? Because each and every microservice, whether it's a clothing, whether it's electronics, and whether it's a payments, we are going to convert each and every microservice as Docker container. Okay, this is one Docker container, and this is one Docker container, and this is one Docker container, and we are going to convert 3 different Docker containers like this. This is for clothing Docker container, and this is for electronic Docker container, and this is for payments Docker container. And we are going to establish a communication between these Docker containers. So each and every application in the microservices will be deployed onto the servers as containers, as Docker containers. Okay, as Docker containers, and there will be a communication between these containers, because the clothing, once the people have selected some clothes, they should do payments, right? In order to do the payments, they should access the payment application by clicking the buttons actually. So once they click on pay button, that the functionality, the API request, the traffic goes to payment application. The payment application does the functionality for you in order to do the payment actually. So there should be communication between the microservices. Because of these reasons, one is resource wastage, and the other one is the evolution of microservices. The Docker is evolved, and it is more popular in the market. It's more popular in the market actually. So that's how the things will work with Docker. Okay, that's how the things will work with Docker. If you have any questions, please ask. Okay, if you have any questions, please ask before going further. Any questions, please, anyone?
Sir, can you repeat on the part where Docker, each Docker application, microservices application being used as a Docker container, that part in little elaboration?
Okay, sure, no problem. Okay, here from the monolithic application, the people has divided the developed as microservices. The individual functionality has been developed as microservices like clothing, electronics, and the payments, right? Here we cannot directly deploy that code on the server, right? The developers developed the application in some particular language. We cannot directly put that language or the code onto the servers. We cannot do that directly, right? So they will be converting this each application, each microservices as Docker images. Okay, this is let me think. This is a 1 second. This is a Docker. Let me take this. Okay, Docker images, and the first Docker image that we have is clothing. Okay, clothing Docker image. Okay, what's the Docker image? We will see. Okay, no problem. Okay, they will convert something as of now. Just assume they will be converted as Docker image. Okay, electronics applications will be converted as Docker image, and the third thing, payments application will be converted as Docker image actually. This Docker image will be deployed as a Docker container. Each application is deployed as a Docker container actually. You cannot directly put the developer code on the server. It is not going to work, right? So they will be converted as a Docker container. Like clothing application that is developed by the developers will be one container, and the electronics electronics application that will be developed by the developers will be second container, and the payments application that is developed by the developers is the third container. Let me label them for your easy purpose. This is a clothing container. Okay, clothing container. This is electronic goods, electronics container actually. Now this is the payments container, PAYMENTS, payments container. So what this container contains actually, clothing container, what it contains internally inside the container, our application will be there, our clothing application will be there. Okay, the electronics inside the electronics container, in case of Docker, our application will be in running state. Okay, inside the payments container, our payments application will be running state. That is developed by the developers actually. These are something called Docker containers, and there will be a communication between these containers. There will be a communication between these containers. Okay, now why the communication will be there? Because once the people got selected some clothes in the Amazon.in application, they should do some payment, right? So the clothing up microservice or the clothing container will be connected to the payments container in order to do the payment like this. Okay, as they are individual applications, individual containers, so there will be a communication between these containers. So in order to do something, some functionality of that particular application here, once the clothing application is to display the clothes, and is to select the cloth for us. Okay, once the clothing functionality is completed, once you selected the clothes in the clothing application Amazon.in, you need to do the payment, right? Once you click on buy button in the clothing section, now the API request will go to the payments application. Within, you cannot see from the console. Okay, but how internally happens is something like this. The API request goes to the payments application, and you can do the remaining functionality that you are going to perform payment, selecting the bank, entering the account number, and entering the password. Entire things, that functionality belongs into the payment container of payment application that is deployed as separate Docker container in case of server actually. So that's the thing. Okay, is that clear?
Yes, sir. Sir, if the is it necessary for the developer to follow this structure microservices? Because sometimes, like, how does it works in the testing, automation testing side?
In case of
Whatever the
automating testing, whatever, like testers will also be writing some test cases. They are going to test, in case of monolithic application, they are going to test the entire application at once, right? So in case of microservices application, each application, clothing application will be tested separately, electronics application will be tested separately, payments application will be tested separately. So it will be becoming easy for us, easy for testers also to test the applications individually, because you need to, if that is a monolithic application, you need to write a huge test case, complex test cases in order to test the monolithic application, because that's there will be dependencies between the each functionality actually. But in case of microservices, you can test the individual applications by simple test cases actually. So it is necessary to going from monolithic to the microservices, because there are huge advantages that we have with microservices that we don't have with monolithic. One of the example I have told you here, one is the dependencies between the different functionality in case of monolithic, and the other one is restart time within the production actually, because of the some of the reasons, many reasons are there like that. Okay, that is the people went to microservices from the monolithic, and the microservices were deployed as a Docker containers on the servers actually. That's how that is going to work. It is necessary, as you say.
okay, sir.
Is that fine?
Yes, sir.
Yeah. Anyone have any questions, please? Anyone have any questions? Okay. If no questions, what we are going to do today is, like, you need to create an AWS account, because everything, whatever the creation of virtual servers, like I have told you, right? This is a virtual server that need to be created. We are going to create in the AWS account. Okay, we are not going to create in your local or anywhere, but I will be showing entire things in the AWS account only because that to save our laptop or to save our laptop with huge load, something like that. So let me show how to create an AWS account actually. So this and all the things we have discussed today, like deploying applications to physical servers and the important terminologies, disadvantages of physical servers, what is virtualization, what is cloud actually. This virtual servers that we are going to create, this virtual servers, internal virtual servers, we are going to use the AWS cloud and we are going to create their, that is the thing. Okay, these are virtualization software we have seen as part of diagram, and this is a thing, and this is a Docker. We have seen application 1, application 2, application 3, and we have seen all the things. Okay, that's a actually we have seen today. Now, how to create an AWS account? Go here and go to the new tab and go to the aws.amazon.com. Go to aws.amazon.com. Click on sign into the console. If you are first time going there, you will be finding their sign up. Just click on that, and if you are second time going there, you'll be clicking on sign in and click on create a new AWS account here. Create a new AWS account here. Click on that. Okay, now once you clicked on that, you need to give your unique email address. Okay, it should not be used previously to create an account. You should give your unique email address, and you need to give your account name. That can be any account name, whatever it is, DevOps or JKD, whatever the name it is. Okay, you need to give your account a name. Once account name and the email address is given, your will be verified by the AWS people, and you will be moving for the further steps. You will be having 4 to 5 steps in order to complete. I don't have a unique email address, so that I cannot able to show you now, because it is as simple as creating your Insta accounts and the Facebook accounts. Okay, that's the thing. Okay, the important step in creating an AWS account is they will ask for your account, like bank account things. Actually, they'll ask for your account number and bank account number, and they will deduct some amount like 2 rupees from your bank account to verify whether it's you or not. Okay, and they will, once the account is created, they will recredit that amount to your account again. And once the account is created by you, that will take 24 hours in order to start that account, in order to use that account. That official documentation states the 24 hours, but before 24 hours only, your account is going to be activated once the account has been created. Actually, if you want to immediately activate your account, you need to contact the AWS support people, so that they will immediately activate your account, so that you can use your account here. Actually, now once your account has been created, once your account has been activated, you need to sign into that account. Now click on the sign into the existing account. Once you click on the sign into the existing account, let it load. Now it will ask 2 things. One is root user, other one is IAM user. You do not change for the IAM user. Just click on this root user. By default, it will be selected. If it is not selected, click on that root user. Now give your email address that you have given while registering, while signing up, while creating your account. Now click on next after giving that. Okay, now it will ask for a password. Give that, enter that. This password you have given while signing up your account. That password you need to give here, and click on sign in. Once you clicked on sign in, you will be into the AWS console. This is the first console that you are going to see in case of once you log into the AWS account. Actually, so we are going to use, for the Docker, we are going to use EC2 machines. That means in case of diagram, what I have told, these are virtual machines. In the virtual machines, right? These are called virtual machines. The terminology in AWS we will call EC2 machines or EC2 instances. Okay, we will call the same machines which I have told in the diagram is called EC2. In the EC2 service, we are going to create a virtual machine, something like that. So you can see here, I have already created 3 different virtual machines. In the same way, we are going to create 3 multiple virtual machines. Okay, in case of Docker, we only required 1. Okay, that's it. Okay, 1 is enough for the Docker. Okay, if you have created your AWS account newly, you will be falling under free trial. It is free for you for 1 year actually. If see, do not think if it is free means you can use whatever you want, but until some limit it will be free actually. If you exceed that limit, it will be charging you. They will charge you. Okay, you can our Docker will come under that limit only. You no need of spending extra things for completing the Docker thing. So that's what I want to discuss. So what we have seen today, we have seen DevOps, we have seen SDLC process, we have seen where does our Kubernetes and Docker fits in SDLC process, and we have also seen the virtualization. What will happen if we deploy our applications to virtual physical servers, and what are the disadvantages if if we deploy our application to physical servers, and because of those disadvantages we went to virtualization, and what are the disadvantages that we have with the virtual machines and virtualization. Because of the disadvantages we went to Docker, and what are the things that we why the Docker is evolved, because of the resource wastage and the microservices evolution. So because of that Docker is evolved, and we have also seen the creation of the AWS account. So that's how you need to perform. That's how we are going further in the close. We have all seen all the things today. So we are going to create a virtual machine tomorrow, and we are going to install Docker tomorrow, and we are going to start our Docker actually. So if you have any questions, you can ask, please. Okay, you can ask. Anyone have any questions? Okay, if you don't have any questions, please put something in chat so that I will be understanding that there are no questions. Put no in chat. If you have any questions, please ask. If no, just put no. Okay. What about the remaining people? Yeah. Concepts you cover was crystal clear. Okay, sure. Thanks for that. Okay. No. Yeah. Now, that's the thing. That's for today. And as of as it is my responsibility to tell you every day, please go ahead and register for the course actually. And we have remaining 2 demo classes tomorrow and day after tomorrow, and we will meet tomorrow. Okay. Thanks everyone. Thanks for joining sessions actually. Thank you.
Hello Shiva.
Yeah.
Hello.
Yeah. Hello.
What kind of materials and videos that you're providing through the course?
See, what we are going to discuss in the course, okay, whether it is a Docker, whether it is a Kubernetes, whether it is Jenkins, what we have discussed in the course, that documents will be uploaded to your drive. You are going to get a drive access which is given to you by the DurgaSoft. The videos, the recordings will be uploaded there, as well as the documents will be uploaded there, so that you will be taking there, downloading there, or you can do from there. Okay, so you are going to get there actually.
The documents that we can download or we can view in the site itself.
See, I don't know what you can do, but I can able to download, so that you can also be able to download. I hope you will be also able to download the documents. No problem with that.
Okay.
Previous days demos as well uploaded.
No, demos will be uploaded to YouTube. You can find the demos in the YouTube channel, at the DurgaSoft channel. You can go there under the playlist. The demos will be uploaded actually. You can find there.
How about today's?
Yeah, can you repeat that?
Today's recording is also being uploaded there, or to our drive?
That will be uploaded to your drive as well as your YouTube playlist actually. Both they will upload. Once you got the access, that will you can see that one in the drive as well as in the YouTube. Okay, the demos will be uploaded in the YouTube also. Both the things.
Shiva, are we going to work on AWS for this Kubernetes cluster?
Yes, because you need to create a Kubernetes cluster, right? So for that, EC2 machines are required, virtual machines are required. Whatever required things for within the AWS for the for completing Docker, Jenkins, and Kubernetes. I am going to use that, and I'll also tell you how to create those clusters in the AWS. I'll also tell some of the knowledge of AWS. Yes, you are right. We are going to see whatever required things in AWS.
Mm-hmm. I tried once from myself creating a KS cluster, but it got built very high. Even I tried with free tier creating
Yes,
Kubernetes cluster. Do we have to
yes.
pay
I am
any amount or?
I am going to show you three ways of creating cluster. One is Minikube way and Kubedium way and EKS cluster way, EKS way. I will be telling you the cost will be happening for Minikube very less cost because that comes under free tier entirely. And if you use Kubedium, little bit cost. And if you use EKS, little bit cost more than Kubedium. Something like that. I will tell you the cost things in case of, then you can decide which cluster you want. For some of the concepts, Minikube is enough. Okay, for some of the concepts, Kubedium is enough in the Kubernetes. So for some of the concepts, EKS should be there. So whenever required, such that kind of cluster you can create, you can practice that things. Then there will be a huge cost reduction for you in the AWS also. AWS actually. So that's how I designed the course.
Okay, thanks.
Yeah,
I'm clear.
yeah, thank you. Yeah. Any questions anyone has, you can ask, or please go ahead and register for the course, and we will meet tomorrow. Yeah, thanks.